So in this video, we're going to talk about, again, a little bit more on conditional probability. So in case we don't remember, conditional probability is, again, probability that's based on assuming certain events has happened first. And so we talked about that last video. We talked about two kinds, actually. We talked about one case where you have a table where you can actually pick out how much of each person represents each category. So we had that table of independents, Republicans, Democrats, and then we also had how many people opposed, supported, or neitered the bill. And then we could figure out our conditional probability just by picking out the right numbers that we need. And then we also had problems such as like number 2 here, where we knew the percent of people that did part A, the percent of people that did part B, and the percent of people that did both, and we could figure out conditional probability using that. So today we're going to be looking at two more types of word problems, one of which we actually have already done before. One is just kind of a very basic twist on something we've done many, many times before. So let's start with that one actually, just to start out a little bit easy. So this is a fractional problem. So something like this would happen. So you have a car plant that manufactures 9 vans, 12 trucks, and 7 motorcycles, and then 2 vehicles are selected at random for inspection. So 2 out of these sets of vehicles are selected for inspection. What's the probability that 2 trucks are selected? So I want the probability that we pick a truck given that we pick the truck first. So again, the probability that we pick a truck given that we already picked the truck the first draw. Well, I could do this whole intersection, union, given, that sort of thing here. Or I can, again, just think about this as a series of events. So we have event 1, and we have event 2. So in event 1, I want to pick a truck, right? Well, I have 12 trucks out of a total of, if we add these up together here, 12 plus 7, that's going to be 19. 19 plus 9 is going to be 28. Let me just make sure I'm doing my math right so I don't have to redo this video another time. 28, right. So we have 28 total vehicles, 12 of which are trucks. So when we draw first, when we pick a vehicle first for inspection, there's a 12 in 28 chance that we pick a truck for event 1 times. Now, if we picked this truck, that means when we go to pick another vehicle, because we can't pick the same vehicle twice because we don't want to expect 2 different vehicles that are the exact same, there's only going to be 27 vehicles to pick from because we picked one of these trucks. And there's not going to be 12 trucks that we could choose. There's going to be 11 trucks that we're looking for. So both these numbers are going to go down. This is just like the marble problems or the without replacement problems. This is no different than a without replacement word problem. It just doesn't say the words without replacement. It kind of implies that. So you pick a truck first, times, you pick a truck again, and again, for a second fraction, you have to kind of reassess the situation to see what happened. And then you just get your fraction or decimal. So 12 out of 28 times 11 out of 27. And we end up getting about 17%, 0.17, that's 6 rounds of 4 up to a 5, so 0.175. So that's a probability that we're going to select 2 trucks. Again, it's a problem we've done before, just doesn't have as much of a doesn't have as much as a clear-cut direction as to what to do there. What's the probability that a motorcycle is selected given that a van was selected first? So the probability that we pick a motorcycle given that we've already picked a van. Well, again, set this up as 2 separate events. Event 1 is to pick a van, right? Because again, this is given we picked a van. So this is actually the first event that happens, and this is the event we want to follow. So there are 9 vans out of 28. So there's a 9 in 28 chance of this thing happening. So that's for van. For the motorcycle, if we're going to pick the second time, that means, again, we only have 27 vehicles to choose from because one of these vans is out. We've already picked that because then that was our given, which means our chance of picking a motorcycle is now 7 out of 27 because we still have all 7 motorcycles. We didn't lose a motorcycle, but we did lose a van. So our bottom number is going to drop by 1, but our top number is going to be just 7 because we still have all 7 motorcycles. So if we go here, let's go ahead and type in 9 for the vans, 9 out of 28, and then 7 out of 27 for the motorcycles, and we get about 0.083. So 0.083 repeating, right? Yeah. And that's the probability that we pick a motorcycle given that we picked a van first. So basically that's the probability of picking a van and then a motorcycle. This is no different, like I said, than the marble problems of without replacement and with replacement that we did last week. It's just, again, a different wording to them. Now, the second type is a little bit different than we've done before. It's kind of like, if I go back here, it's kind of like the second type of problem that we did in the last video, except that instead of giving us percentages, they're going to give us actual number values about population. So it's kind of a mix between these two, actually, is what I could say there. It's a mix between problem type 1 and 2. So we have a class of 60 students. 33 of them are seniors. I said 33 of them are, not A, but 33 of them are seniors. 30 of them are math majors, and 8 are neither seniors nor math majors. What's the probability that a randomly selected student is both a senior and a math major? So we're picking one student, and we want the probability that he's both a senior and a math major. So basically, we want the probability of A and B, right? Because if we say probability of A is a senior and probability of B is a math major, this is the probability that they're a senior and math major. Because again, and is that upside down U, or otherwise known as an N symbol. So when in these types of problems, it's good to just kind of get a layout of what are all the probabilities I can get right away. So I know that the total amount is 60 students, which is a big help. 33 of them are seniors. Now, again, these seniors, some of them are math majors, some of them are not. But I know that 33 of them are seniors. So the probability of me getting a senior is 33 out of 60, which ends up being about, let's see, 30 out of 60 would be 0.5, so it'd be 0.55, about 55%. 30 of them are math majors, so it'd be 30 out of 60 are math majors, which is exactly half. Half the class is a math major, so it must be some sort of math course. And then 8 of them are neither. Now this is a little bit tricky to think about. Neither means it's not A or B, so neither is not A, I should say nor, but I'm going to say or, and you'll see why in a second. Not A or B. So not A and not B, or not A or B. I should say not, let's do it this way, not A or B. Not A or B. So that is basically the probability of A or B negated. Because remember, this is the probability of A or B or both happening. I want the probability of neither of them happening. So neither is basically the negation or the complement of A or B. So 8 are neither, which means that 8 of here would be 8 out of 60. Let's see here. That'd be, brain moment here, 0.133. So 0.13 repeating. So again, when you hear the word neither, this is very important for this here. When you hear the word neither, that is the complement of the or. So neither, think of neither is equal to 1 minus the or. So that's what neither means, neither, is 1 minus the or version. Now, because of that, I can actually use the complement rule to switch them out. So I can say that the probability of A or B happening is simply 1 minus the probability of neither of them happening. And again, if you think for a minute, that kind of makes logistical sense there. If I have 1, which is everything, and I take away all the chance of neither of them happening. So I take away the chance of A not happening, I take away the chance of B not happening, I take away the chance of A or B not happening, I take away all those cases there, then what I'm left with is either A or B. Could be both, could be A and B as well, but probability of A or B is simply 1 minus the probability of neither of them happening. So 1 minus 0.13 repeating. And this would end up giving you, let's see, that'd be 1 minus 8 out of 60. Let's just do this here. So 1 minus 8 out of 60. That gives me 0.86 repeating, or if we make it into a fraction, 13 out of 15, duh. So 0.86 repeating, or 13 out of 15. Right? Again, you can always change your decimals into a fraction by going to math, frac, and then it will change whatever answer you have into a fraction, if it can be. Some decimals cannot be made into a fraction. So if it doesn't give you a fraction back, it means you have a decimal that can't be made into a fraction. So FYI. So now that we can get the and, remember our goal, this question here was asking what's the probability of that he is both a senior and a math major. So we want the and probability. Well, now that we have the or probability, we can get the and probability by using the formula. So the and probability is, again, the probability of A happening plus the probability of B happening minus the probability of them happening together. Again, this is to get rid of the double count. So the probability of A, we know, is 33 out of 60. The probability of B, we know, is 30 out of 60. And the probability of either of them happening, A or B, is up here 13 out of 15, which if I make this out of 60, what's 13 out of 15? So 15 times 4 is 60, right? So 13 times 4 would give me 52, so it'd be 52 out of 60, which again makes sense because if there's 8 ways of neither of them happening, it means 52 ways of them or happening. So we subtract our top numbers when we're subtracting fractions, right? 33 plus 30 minus 52, and we get the fraction 11 out of 60, which ends up being the decimal, if you want it, of 11 out of 60, 1.183 repeating. So 0.183 repeating. So this is the probability of the student being a senior and a math major. And again, in order to get the and probability, in order to get the and version, you have to get the or version first, because this is going to act as your double count that you're going to subtract out. So you have to get the or version first before you can get the and version, which is why we had to have this neither thing, and that's why this neither part is important here. So one of the main key takeaways from this lesson here is to understand that neither is the complement of or. So if you want to get the or, you take 1 minus neither, and that gets you the or version. And then you can use the or version to help you get the and version using our intersection formula here. Again, this is a formula you're going to want to make sure you're very comfortable with. Now, let's take the same scenario and just kind of switch up some questions you might be asked. So that wasn't really a conditional probability one, because that was just asking you, okay, you have a student, what's the probability that he's this and that? But the reason we had to get the and version, so we had to get the or version to get the and version. The reason we have to get the and version is because, remember, to get the conditional probability, you need the and version. This is how you get the conditional probability of a situation. The probability of B given A is the probability of both divided by the probability of A. And remember, the way we explained this last time is like this is your pool that you're picking from. So in this case, it says, given that the student selected is a senior, what is the probability that they are also a math major? So this is kind of like saying, if you select a senior from all the seniors, what's the chance that they're also a math major? Now, unfortunately, I don't know how many seniors are math majors. I don't have a two-way table like we did in the very first problem in the last video. Otherwise, I could make this work very easily. But I can use this probability formula here for conditional probability to help me out there. So the way I get the probability that they're a math major, given they're a senior, is I take the probability that they're both, which if you don't remember, the probability that they're both is, we just found out here, 11 over 60, or 0.183 repeating. A and B is the same thing. Whoops, sorry. Wrong one there. The probability of A and B is the same thing as the probability of B and A. So these are interchangeable. So don't get every time. I tell you, man. Don't laugh at me. So the probability of A and B is the same thing as probability of B and A. So again, that's why this can just be interchanged here. So what we're going to do now is we're going to take that number and we're going to plug it in into our formula here. So we're going to take this value here, 11 over 60. 11 over 60 on top. That's the probability of B and A, divided by the probability of A, which is, let's see here. A was that they're a senior, because again, this is our given probability here. So given that the student selected is a senior, so that means that we're going to have 33 out of 60. So 33 out of 60. And we're just going to divide these two fractions. Now, again, you can do this in a calculator. So 11 out of 60 divided by 33 out of 60. And that gives you 0.3 repeating. Or, again, you can know how fractions work. If I have 11 out of 60 divided by 33 out of 60, what basically happens is the denominators cancel. So this goes away, and I'm simply left with 11 out of 33, which is where this 0.3 repeating comes from. 11 out of 33 is 0.3 repeating. Sometimes they might ask you to write your answer as a fraction, so it's good to know this trick here. If you want to know the behind the scenes version, the way this actually works is 11 over 60 divided by 33 over 60. What happens is you write this as a division problem, 11 over 60 divided by 33 over 60. And remember, your second fraction flips. So 11 over 60 times 60 over 33. And then you cross cancel, and then you're left with, again, 11 over 33. So that's why the denominators just cancel out. When you have a fraction divided by a fraction and the denominators are the same, they just cancel out, and you're left with just this number over that number. So if they do ask you to write your answers as a fraction instead of a decimal, you can always do it this way. Or like I said, you can get the decimal version and just go math, fraction, and then you can get the reduced fraction, which is actually 1/3, which is probably what they would want you to write down, because 11 over 33 does reduce down to 1/3. So the last version of this is just asking it backwards. So what about if they say that you picked a math major and you want the probability that they're also a senior? So instead of being B given A, it's now A given B. And again, it doesn't change at all, really. The top is still 11 over 60 because, again, A and B and A are the same probabilities. So this is always going to be 11 over 60. The top number is not going to change. What's different is that the bottom number, remember, the bottom number is the probability of this event right here, of your given event. So if you're given that they're a math major, the probability that they're a math major goes on bottom. So the bottom number in this little conditional probability version is always the probability of the given assumption. So in this case, I'm given that they're a math major, which if we look back here, the probability of that happening is 30 out of 60, or 0.5. So the probability of me getting a math major is 0.5. So 11 out of 60 divided by 0.5, which if we do this here, 11 out of 60 divided by 0.5, and then that'd be 0.36 repeating. So 0.36 repeating, or if they want it as a fraction, we can go to math fraction, and we get 11 out of 30. So again, either of these answers work, just depends on what they ask for. So to make sure you read the directions and put it in the form that they need. So that's it for this video. Again, it was kind of a short one here because we only really had two types to go over, and one of them is one we already did. Just remember that, again, when you're doing the conditional probability, your given probability is always the one that goes on bottom because this is the people you're pulling from. So you have to kind of first figure out, okay, given that they're a math major, so that's going to go on bottom because that's the people I'm picking from. And then the chance that they're both is going to be the one that I want to be on top because given that they're a math major, I want to take it another step further and get the chance that they're both. So out of the math major people, how many are both? And that's where you get this little fraction from. So that's it for this video. Hope to help you out. Have a good day. And that is legit.